Hello, James Flaten here with the Minnesota Space Grant with some tips about soldering. This is the second of two videos, and so I'm assuming that you've actually seen the first video, which were soldering basics. So you know something about how to solder. I just want to give you some tips about how to do it better. And I'm going to, again, just limit myself to through-hole soldering. A couple of things to start out with. First of all, the smoke. We're talking about the rosin smoke and how you shouldn't inhale it. It's possible, I don't have one here because I don't use these, but it's possible to buy some sort of a fan. It's a little tiny fume hood almost that will draw the smoke away from the user. And so you could look into that if you're worried about that smoke or if your institution is worried about that smoke. But in actuality, my claim is as long as you don't go out of your way to inhale the smoke, you'll be fine. The second comment has to do with protection of surfaces. So this is another safety comment. When I'm doing soldering or having my students do soldering, very typically it's in an area that's not really intended for that use. So it's not like in a laboratory area with heavy duty benches and stuff. So I tell people to work on an object like this. So I call this a cutting board. It's just a 2 foot by 2 foot piece of flooring that I buy from Home Depot. And essentially, I don't really care if I get drips of epoxy or drips of solder or something onto this kind of surface. On the other hand, one problem with this surface is that it's so variegated that it's hard to see the parts if you have this in a video. So I'm actually doing my video over a cleaner surface than this, but normally I would solder on something of that sort to protect the surface that I'm working on. Okay, let me share my screen. Get back to my workspace here, and let's talk about wire. So here's a couple of wires. This is one of the issues that you'll have to deal with soldering is what kind of wire to use and what's the appropriate size of wire, frankly. So if you're using a solderless breadboard, typically you would use what's called solid 22 gauge wire. So here's actually some solid 22 gauge wire. Solid just basically means, as you might imagine, that there's a single piece of metal within the plastic insulation. Let me strip this wire. So I'm going to put it in the number 22. I'm going to clamp down and pull, and there it is. It's a solid piece of wire. And then here's some actual 22 gauge wire that happens to be stranded. So same deal. Stick it in the number 22, clamp down, pull. And notice when I do that, it comes out as many individual pieces right there. Okay, so you might say that doesn't look good, but it turns out that stranded wire for soldering purposes is almost always better. So I would use solid wire if I was plugging into a breadboard, for instance, because you can't push stranded wire into a breadboard very easily at all. But for almost all other situations, stranded wire is better. It's more flexible. It actually conducts electricity more effectively. And frankly, if you were to take the strands and basically screw them together like this, and then infuse that part with solder, it becomes essentially solid. So if you really need the end to be more or less solid, you can make it that way, but the wire itself is just more forgiving. So almost all soldering tasks benefit from using stranded wire, not solid wire. One problem with solid wire actually is that if you are stripping it and if you happen to nick the metal just a little tiny bit, you can cause a crack, and that crack can propagate and basically the entire thing can fall off, if not right away, possibly in the future. In the case of stranded wire, if you nick it, well, that probably means you cut a strand or two and those strands aren't any good anymore, but the rest of the strands should be fine. Okay, so let's actually do a quick demonstration here of tinning. Tinning means infusing this end with solder. So here's my iron, and I'll turn it on. Okay, that'll take a couple seconds to warm up. Let me get that over here in the corner. So there's my tip. So while I'm getting ready to do this, let me pull out a helping hand device. And this will hold the wire so I don't have to. And then, as was always the case, I want to get the piece hot. and then bring in the solder. So when I first turn on my iron in particular, I very often will take my solder and touch to the tip and just see if it's melting. And yes, indeed, it is melting. So that just means it's hot enough. So now I bring my tip and touch the wire to get the wire hot. And then I'm going to start to infuse the wire with solder, just moving along. There it is. So now essentially the wire is basically solid. And if I end up with a little bit of extra solder, maybe on one end of it, which I did, clean off my iron, and I might decide that I want to even clip off that bit, holding it so it doesn't go flying, throwing away the part that I wasn't interested in. Okay, so there is a tinned piece of stranded wire. Now, a very typical thing to do, which is a little tricky, is to, for instance, attach a piece of wire to, let's say, a header. So here's a male header. The long part of the male header is the part that's supposed to plug in to something, like, for instance, plug into a breadboard. So let's assume that I want to attach a header to a piece of wire so I could plug it into a breadboard or to a female header or something like that. That means I need to attach it to this side, the short side. How might that work? Well, for instance, I could grab the header with one of my helping hands, grab the wire with another one. Even if you're using a helping hand that has two, sometimes it's tricky to get them to hold just at the exact spot. So I sometimes even use two of those, but in this case, I'm going to use two individual helping hands. And what I want to do is I want to hold the wire just where I need it, so that when I'm bringing in my solder, I literally am only doing the soldering and I'm not also trying to hold the pieces. These helping hands are a little bit tricky to use because they don't want to be twisted. Trying to get them to twist so that they stay level. There we go. Let me bring this over. Notice that the exposed amount of wire here is really longer than necessary. It would be better if I had clipped this down to be exactly the right length. But I'm actually going to solder it this way, just for a later demonstration. Okay, so here we go. The wire is already tinned. But the next thing I want to do is I actually want to tin the header. So that just means put a little bit of solder on the tip of the header right there. This is, of course, the short end. This is the end that I want to be soldering on. So notice there's a little tiny blob of solder. That's okay. I'm going to clean off my iron. But now that the wire has solder on it and the header has solder on it, it's actually very easy to connect the two together. You just have to get them touching where I want them to be touching. Put down my iron while I'm getting this thing lined up. There we go. And then I don't have to worry so much about holding them in the right spot. The helping hands will do that. All I need to do is just touch that solder. And when I touch that solder, the two will naturally stick together. Oh, man. Okay, so there's a solder connection. If I can zoom in on that. Not the prettiest thing, but it certainly is electrically connected. It's not particularly well mechanically connected, I will admit that. Okay, and so I'll give you some suggestions about how to improve the mechanical connection. But there is one significant problem here, and that is that there is so much extra exposed metal. So for instance, here is where the solder went right there, but all of this stuff was unnecessarily exposed, and so it probably would have been better not to have that stripped in the first place. But if necessary, I can cover that up with something that is electrically insulating, like shrink wrap or like electrical tape. Let me talk about those two things separately. So shrink wrap, also called heat shrink tubing, basically is tubing that when you heat it up, so here I've cut a little piece of it. When you heat it up, it will shrink. And so that will cover something up. So this is the coolest way to go. You'd have to, in this case, feed on the tubing from the far end. And it turns out that under some circumstances, you don't have access to a far end. So you have to be a little bit thoughtful about how to use the tubing. And slide the tubing until it covers up everything. Make sure you use big enough tubing to get over the top of that. And then I could shrink that. How do I shrink that? Well, I have to use a heat gun. So here's my heat gun. And so there's one problem, shall we say, with heat shrink tubing is it needs additional equipment, and it also needs sort of additional planning. I'm actually not going to do that. I don't use heat shrink a lot. I actually prefer electrical tape under most circumstances. So here's some electrical tape. But let me just point out something about electrical tape, and that is, well, it's tape. That means it's sticky on one side and not sticky on the other. And interestingly enough, although it doesn't look as cool, it really is much better if you apply the tape so the sticky side of the tape sticks to the sticky side of the tape. So here's a piece of electrical tape. If I wanted to cover this thing up, what I might be inclined to do is feed the electrical tape underneath the piece this way. And notice I'm not wrapping the piece in electrical tape. It's sticky here and sticky here, and I'm just going to fold the electrical tape over on top of itself. So it's sticky to sticky. This is a bit like a flag sticking out the side of the wire. This does not look as neat. I will concede that. On the other hand, it really, really does work better. So then I would perhaps trim this off. And I would consider that well insulated. And if I had pieces next to it, each one of them could be insulated so they wouldn't inadvertently touch each other electrically, even while I'm handling the device. Okay, let's talk about, and notice I used two helping hands, one to hold the wire, one to hold the piece so that I could get the two pieces exactly where I needed them to be and didn't have to worry too much. I also tinned both of them in advance. And so when I brought in my soldering iron, I didn't even have any extra solder on it. I just used the iron to melt the solder that was already on the two pieces. Let's talk about what do I want to talk about next? Let's talk about solder bridges. These are tips, but they are not in any particular order. So here's a piece that I was working on in my last video. No, this is not the piece I was working on in the last video. This is the finished piece. Yes, indeed. So I think in the last video, I didn't show you the fact that when you finish this, it will flash. Yeah, that's why it's called a flasher circuit. Okay, so that's where you're supposed to be heading with the flasher activity. I can find a piece that I was starting to work on in the last video and talk a little bit about what could have gone wrong and how one might proceed to fix such a piece if something has gone wrong. So for instance, I just put on two components only so far. The two components were the socket and the capacitor. They're both soldered on this side. And so remember, I needed to make sure that none of the pads there had so much solder on them that the solder bled over onto a nearby pad. So notice that some of the traces there are relatively close together. They're not touching. There's always plastic in between them, that's for sure. But you could imagine if you put so much solder onto one of these solder pads, it might just have to go somewhere and it might flow over. That's called a solder bridge. And so if you have a solder bridge, which I do not have a solder bridge here, but if you have a solder bridge or for any other reason you want to replace a component, let's say that I put that capacitor in backwards. Again, I didn't do that, but you might be interested in removing the solder. So let's just talk a little bit about solder removal. Here are two things you would like to know about, I think, for solder removal. One is called desoldering braid or solder wick. Okay, there it is, solder wick. The idea is solder wick is actually really finely braided copper wire. So finely braided that solder likes this better than it likes that. So one possibility for getting solder off is just to melt the solder and touch it to a hot braid, and the solder will actually wick into the braid and leave the piece. So let's try that first. I'm going to hold my piece with a helping hand. I'm going to lean the piece so it's actually touching the surface here, which means that I can push against it if I need to. And let's say that I'm interested in removing this solder on this side. So first of all, here's my clean iron. And if I touch that part rather quickly, I can melt it. There it is. It's fully melted now. Okay. It's not, I'm not removing any solder. I'm just pointing out it doesn't take long to melt it. So now how can I get rid of that solder or get at least some of it off there? And the answer is take the wick, and I want to melt the solder with the wick touching it. Okay, so here it is. And what will happen is the solder, once melted, will penetrate the wick and will leave the part. Let's see how I'm doing here. Keep going. It's a little while. This is a situation where it might actually be handy to have my temperature a little bit higher. Just because I'm trying to get sort of extra stuff. I'm going to turn up my temperature on my iron. Okay, so I went up from 330 to 380 degrees Celsius. And there it is, easy to melt. Just want to melt it with the wick in place. There we go. Aha. So if I look at that now, I can see that essentially, zoom in on that. Essentially, I've gotten almost all the solder off of that pad. Maybe it's loose, maybe it's not quite loose, but definitely the solder is mostly missing. Okay. Let me use another device to get the solder off the other side of the same thing. Okay, so here we go. The second device that I'm going to propose, this is a little bit more complicated. I don't use these very often, actually. It's called a solder sucker. So a solder sucker is a cock device. The idea is you cock it, and then when you press this button, it sucks. And so basically it's going to pull through this nozzle here, which is temperature tolerant, apparently temperature tolerant plastic. It actually can suck the solder out of the way. So the key is to cock it and then melt the solder and then bring this close and suck the solder out by releasing it. Let me try that. Okay, so I'm going to go to this side. I'm going to get the solder melted. There it is, completely melted. Bring the solder sucker in and suck. I got some of it. See if I can get any more of it. Get it melted. Bring the solder sucker in. Let's take a look at that one. So now I've managed to basically get the solder almost entirely off of both of those pads. The piece isn't falling out exactly, but in fact, the piece is coming out. Basically, there was so little solder left that I was able to get the piece out. I just need to be very careful when I put the piece back in that I get it in the right way around. Luckily, the minus sign is well labeled here. So there's a couple ideas about getting solder off of a part. If you need to, for instance, replace the part, put it in the other way around, for any reason. Let's talk about attaching wires together. So here, for instance, is this solid wire that I stripped before. Here's this piece of wire. It has the header on one end. Let's assume that I want to attach these wires end to end. Okay. Well, first of all, I need to strip this wire. So stripper. I will strip about the same length, maybe about 1 centimeter in this case. Now, a possibility here would be just to lay the wires side by side and try to solder them together. That can work, and that will definitely give you an electrical connection. On the other hand, that's not the best way. turn my iron temperature back down again. Better approach, and that is, first of all, twist this one because this is the stranded wire. I don't want any individual strands to go anywhere besides there because that could cause a short. The next thing I'm going to do is I'm going to actually bend over this wire. And so since this is solid, this is a little harder to bend. And if it was thicker than 22 gauge, I might not be able to do that by hand, but I could certainly use a tool. Let me bend over this wire as well. So in other words, I sort of have U shapes now in both wires. And then I'm going to hook them together. And when I hook them together, now I essentially have a mechanical connection. And then if I flood this entire area with solder, the solder will establish and hold an electrical connection, but it's not being counted on for mechanical strength because solder is not particularly strong mechanically. So here we go. I'm going to hold this with one helping hand. I'm going to hold this with the other helping hand. I'm going to pull them slightly apart. So this is in a little bit of tension. And now I'm just going to add some solder, basically to just kind of fill in all those gaps. So there we go. That's the solid side. The stranded side might be easier because this was not pre-tin now that I think about it. But anyway, so essentially now I have solder right across that gap. And this is stronger than if it had been solder only because the two wires are bent around each other. Okay. Well, I'm just going to do this here. So, let's talk about the tip. So remember, the tip of your soldering iron should stay really shiny and not have any excess solder on it. So I keep wiping the tip off. This is a new iron, so its tip is still shiny, but if the tip happens to get corroded, here's a couple ideas. I'm not going to demonstrate either one, but I'll just mention them, and that is, it's possible to literally use sandpaper and sand down the tip to try and get back to sort of bare metal, to sand off the oxidation. Another possibility, I just don't have any around with me here, is using what's called tip tinner. It's a chemical. It's a little bit like rosin, as in it's a chemical for cleaning, but in the case of tip tinner, it's a chemical for cleaning tips. And so you get the tip hot, you immerse it in the tip tinner, which is kind of a solid material, but it will melt when you touch it. And then you can get your tip to be nice and shiny again. So one thing to watch for. We just did headers. This is a male header. Let's talk a little bit about soldering some headers onto, for instance, a breakout board. So there's a breakout board. It's got a place for 4 headers to stick through those 4 holes. So here's how I might approach that. First of all, if I had a header strip, I would cut off a piece of 4, assuming that I don't need this header strip in its totality for anything else. So there are notches in between the various pins here. And so I can just get my wire cutters right there, hold both sides, snip, there it is. So there's a piece of 4. Male headers are particularly easy to separate this way. Now what I'm going to do is I'm actually going to use this. This is my solderless breadboard to hold my male header. So I push the male header down and to hold my piece. Let me go ahead and do the soldering. Here's my recommendation, and that is solder one end of it. So I'm just going to solder this end, which says ground, GND. Touch the pad, touch the pin, which is the header. Bring in the solder. Let it soak in a little bit. In this particular case, it can even soak into the hole that the pin goes through. There it is. That wasn't hard, but I did make one mistake. It was intentional. Take a quick look at that. Okay, so the one is soldered right there, but the mistake is the thing is actually not perpendicular to the header right now. It's sort of hanging down a little bit. Okay, if I were to pull this out and turn it around, it will be a little bit more obvious that it's not perpendicular. Okay, there we go. So What I really want to do now is I want to get that to be perpendicular. And so what that means is let's reflow it. So I'm going to touch this, check on focus, get it to be fluid. There it's fluid. Get it to be perpendicular with my hand. I'm just holding it perpendicular, and then take my iron away and let it cool perpendicular. Now that it's basically perpendicular, I can go ahead and do the other three if I wanted to. So that's why having a solderless breadboard for holding parts is actually quite useful, especially headers, male headers in particular. That's essentially what this is. This is all female headers, and you plug in things into it. Plug in male header. Now, here is an issue with male headers in general, and that is, in this particular case, perhaps you want to solder on this short end so that you can leave the long end for plugging in things. But notice that the two are held by a plastic piece, and if you get this too hot, it will literally melt the plastic, and if you melt the plastic, then the entire pin will fall out. Okay, so the way to avoid that, and I did it a moment ago when I was adding that header to the wire, but I didn't point it out, is I want to take the part that I'm going to solder, and I want to attach it to something that is metal and is significantly bigger than the pin itself. That will serve as a heat sink. Okay, so the idea is now when I heat this up, it literally won't get as hot as maybe you would like it to be, but it'll get hot enough for solder, that's fine. And it won't get so hot that it will melt the plastic. So in other words, the pin won't get loose as long as you do a heat sink. This is actually easy to do. Just don't do the following. Don't clip here and then solder on the other end. You've got to solder on the end that has the heat sink on it. Okay, and if you want to solder on the other end, put your heat sink on the other end and then solder on the other end. Female headers are a little bit trickier, and the reason is they don't separate as easily. So here's a female header, and let's assume that I want to attach a wire to one end of that. In fact, sure, I will grab myself a wire. Here's a piece of wire. This happens to be some solid core wire. It's actually two parts that are attached together. And if I were to be interested in, for instance, putting some shrink wrap on this, I would actually have to pull these apart far enough, put the shrink wrap on to get it away from the heat, do the soldering, and then slide the shrink wrap back. So that's why shrink wrap requires a little bit of planning. But let's just say that for now, I want to solder these two pieces onto the first two of this female header. Now, and let's say that that's all I want. I want exactly a two-position female header. Well, you might say, let's just cut it apart. So I've got the two positions, and I just want to cut in between those first two and the third pin, and almost guaranteed you'll destroy something. In other words, it's very difficult to cut between two pins on a female header. You can do it easily on a male header. You can't do it easily at all on a female header. So here is a better approach, and that is sacrifice a pin. So if I want two, what I'm going to do is grab the third one and pull it out literally. So there it is. I've extracted the third pin, but now I've given myself a pretty big cutting area. So if I want to cut in between here, there it is. And this one is not damaged, and this one is not damaged, and there is some extra plastic in there, which you might want to clip away or sand away. On the other hand, if you are tight for space, you might not bother. I can clean this up a little bit. Notice that I'm covering it as I cut so that I don't get parts flying around. These aren't metal parts, but they could still fly around. Okay, so that's a little cleaner, a little bit neater. I'll even do the other side. If you're tight for space, this might be necessary, in fact. So there is a two-position female header. And now let's say that I want to attach this wire to it. Let me separate that a little bit more. Let me strip that wire. In this case, I'm only going to strip it approximately the length that I really need. That would be more appropriate. So there it is. That's about the length I really need. That's fine. But here's a mistake. Okay, the mistake is you might say, okay, hold the female header like that. Hold the wire. and go to town on soldering. The mistake is that the female header is not attached to a heat sink. It's attached to something, but the something is touching plastic, not metal. Okay, so it's quite possible that this female header will overheat and that pin will fall out. Here's a better approach. A better approach is to take the female header, take a male header, which we're used to using, and we know how to do a heat sink, plug in the male header into the female header, and now hold on to that. Okay, so now I'm actually holding on to both pins, so both pins have heat sink on them. Let's reverse these. Okay, there we go. Now I'm ready to do a little soldering. Happens to be solid core wire, that's okay. So here's how I might proceed. Grab my iron, grab my solder, put a little bit of solder onto this pin right there without getting anything too hot. Put a little bit of solder onto this wire, like that. So in other words, I'm tinning both. Getting a little tiny bit of solder ready on each of them. Clean my iron. Get them ready, get them in position. Then as I did before, what I'm going to do is I'm just going to bring the iron in. The iron is clean right now, but when I melt it, it will essentially melt all the solder that's on the parts in the first place. And in fact, I probably could have even stripped that a little bit shorter. There they are. But remember, I could easily put electrical tape on that, but I can't really get shrink wrap on that because I had to put the shrink wrap on before I did the soldering. So had I wanted shrink wrap on this, I would have to unsolder it, slide the shrink wrap on, resolder it, slide the shrink wrap back up, and then shrink it. Electrical tape, you can put it on anytime you want. Okay, so a little bit about cutting and using male headers and female headers and the concept of heat sink. A couple other things. Let's talk about soldering something that really doesn't like solder. Here, for instance, is a thermistor. We use thermistors pretty regularly to measure temperature. A thermistor is just a temperature-sensitive resistor. But it turns out that the leads on the thermistor actually are not copper. In fact, I think they're probably steel, stainless steel, something like that, something that doesn't actually like solder very well. And so, frankly, it's a bit hard to solder onto a thermistor. So here's what I'm going to do. I'm going to grab some wire. So let me just cut off a piece of wire here and show you how I might approach this problem. I want to attach the two leads of the thermistor to other wires so that I can plug them in or something like that. And notice that the wires on the thermistor are not insulated. So that's another reason for doing this. Here's what I'm going to do. I'm going to take this wire. I'm going to strip maybe about a full centimeter. I'm going to twist it shut. And then I'm going to take the thermistor lead and wrap it around the other wire. So here we go. Here's my thermistor lead, and I'm just wrapping it. And then I'm actually going to slide it until the thermistor is off the end of the other wire. Then I'm going to hold this piece in a helping hands, and I'm just going to essentially infuse that entire thing with solder. And so even if the wire on the thermistor doesn't really care for solder, it just can't help but be attached. Here comes my hot iron, here comes my solder. And when I infuse the wire that likes the solder, the wire that doesn't care for the solder will get covered by solder anyway. Okay, so there it is. So that's a possible approach for soldering on a thermistor with wires that don't take solder very well. In this particular case, now that it's done, I would clip off that excess, do something similar on the other side, And for instance, I might be inclined to cover this one up with a heat shrink tubing, which I can bring in from the bottom. Okay, it covers all the way over the soldering part and also covers over a little bit of plastic. Here's actually another thing that can happen, a mistake, I guess, and that is if you get too much solder in there and then you shrink this down, you can actually squeeze the solder out. In fact, just for fun, I'm going to try that. I'm not sure I necessarily have too much solder, but let me plug in a heat gun. And what I'm going to do is I'm going to shrink it. And I'm going to watch for any solder to be oozing out. So I'm going to shrink it more than I really would have to. So that's about as much as I would really like. That has shrunk down. But if I keep going, there it is. Notice the solder is kind of coming out the top there. So that, in other words, I shrunk it so much, I heated it so much that the solder underneath melted. And once melted, it started to get squeezed out. That's not terrible. It's not great. But so here is my proposal now to fix that. And that is, with that solder sticking out now, you've kind of defeated the purpose of trying to keep this thing from touching anything else. But luckily enough, that solder is not really well attached to anything. And so once it cools, hopefully it's cool by now, I can actually just break that off with my fingers. So there it is. That little solder bead came off, and I'm back to what is a pretty reasonable insulated piece. On the other hand, it would have been better had I not squeezed that solder out in the first place. And so just don't heat your shrink wrap so much that you melt the solder that's underneath it. Okay. The last thing I want to mention, again, in no particular order, is if you're trying to put parts onto a printed circuit board. Here's an example of a printed circuit board. Or here's a printed circuit board that doesn't have any parts on it. And so in this particular case, you get to choose in what order will I put the parts on. So this particular board is going to have some headers that go along and a TC that plugs into it, and we'll have some more headers over here and some terminal blocks here and etc. This one already is reasonably well populated. Does it matter the order in which you put parts in? And the answer is sort of. Okay, here's my recommendation. First of all, if I look at this board, I will notice that the parts aren't all the same height. Okay, and so the simplest suggestion is solder in the parts from shortest to tallest. And the reason is if you're soldering in these headers, for instance, they all stick off the board the same height. And so you can place the board upside down, sitting on the headers, and do all the soldering. But you can't do that soldering if you've already put in a piece like this piece here that sticks up higher than the headers. So also pay attention to the parts that have long leads that stick through and can be splayed, because those parts will hold themselves in place if necessary. And the parts that have very short leads, and so they have to be held in place. Or another possibility, like I said, is just to let the thing sit upside down on top of the parts. So I guess for this thing here, here's what I would propose. I would propose taking some of the very shortest parts. So this is the thermistor right here. There's a couple of resistors underneath there that are close to the board. I would do those first. Then I would probably do these switches because they're very short. Then I would do these switches because they're slightly taller, but still shorter than the LEDs. I might do the LEDs next. And then the things that are pretty much all the same height. For instance, these terminal blocks are about the same height as these headers, are about the same height as these jacks. Those things could more or less be done all at the same time. These things here look tall, but in fact, they're not tall. They're just headers with something plugged into them. And so the thing that's plugged into them comes in later. That's not to be worried about as far as this height issue. And I have some plastic parts which were added later, so don't worry about those. On the other hand, there is one genuinely tall part. It's this part right here. Okay, so this part here really does stick out higher than anything else. So I would definitely plan to do that last, because once that's in place, the thing won't sit down very well anymore. I think that's what I've got for tips. Good luck on your soldering.